On the Revolutions of the Heavenly Spheres by Nicolaus Copernicus. Revolutions, Book 1. Introduction. Among the many various literary and artistic pursuits which invigorate men's minds, the strongest affection and utmost zeal should, I think, promote the studies concerned with the most beautiful objects, most deserving to be known. This is the nature of the discipline which deals with the universe's divine revolutions, the aster's motions, sizes, distances, risings and settings, as well as the causes of other phenomena in the sky, and which, in short, explains its whole appearance. What indeed is more beautiful than heaven, which of course contains all things of beauty? This is proclaimed by its very names, Caelum and Mundus, the latter denoting purity and ornament, the former a carving. On account of heaven's transcendent perfection, most philosophers have called it a visible God. If then the value of the arts is judged by the subject matter which they treat, that art will be by far the foremost which is labelled astronomy by some, astrology by others, but by many of the ancients, the consummation of mathematics. Unquestionably the summit of the liberal arts, and most worthy of a free man, it is supported by almost all the branches of mathematics. Arithmetic, geometry, optics, surveying, mechanics, and whatever others there are all contribute to it. Although all the good arts serve to draw man's mind away from vices and lead it towards better things, this function can be more fully performed by this art, which also provides extraordinary intellectual pleasure. For when a man is occupied with things which he sees established in the finest order, and directed by divine management, will not the unremitting contemplation of them and a certain familiarity with them stimulate him to be the best and to admiration for the Maker of everything, in whom all are happiness and every good? For would not the godly psalmist, 92:4, in vain declare that he was made glad through the work of the Lord, and rejoiced in the works of his hands? Were we not drawn to the contemplation of the highest good by this means, as though by a chariot? The great benefit and adornment which this art confers on the commonwealth, not to mention the countless advantages to individuals, are most excellently observed by Plato in the Laws, Book 7. He thinks that it should be cultivated chiefly because by dividing time into groups of days, as months and years, it would keep the state alert and attentive to the festivals and sacrifices. Whoever denies its necessity for the teacher of any branch of higher learning is thinking foolishly, according to Plato. In his opinion, it is highly unlikely that anyone lacking the requisite knowledge of the sun, moon, and other heavenly bodies can become and be called godlike. However, this divine rather than human science, which investigates the loftiest subjects, is not free from perplexities. The main reason is that its principles and assumptions, called hypotheses by the Greeks, have been a source of disagreement, as we see, among most of those who undertook to deal with this subject, and so they did not rely on the same ideas. An additional reason is that the motion of the planets and the revolution of the stars could not be measured with numerical precision and completely understood, except with the passage of time and the aid of many earlier observations, through which this knowledge was transmitted to posterity from hand to hand, so to say. To be sure, Claudius Ptolemy of Alexandria, who far excels the rest by his wonderful skill and industry, brought this entire art almost to perfection with the help of observations extending over a period of more than 400 years, so that there no longer seemed to be any gap which he had not closed. Nevertheless, very many things, as we perceive, do not agree with the conclusion which ought to follow from his system. And besides, certain other motions have been discovered which were not yet known to him. Hence Plutarch too, in discussing the sun's tropical year, says that so far the motion of the heavenly bodies has eluded the skill of the astronomers. For to use the year itself as an example, it is well known, I think, how different the opinions concerning it have always been, so that many have abandoned all hope that an exact determination of it could be found. The situation is the same with regard to other heavenly bodies. Nevertheless, to avoid giving the impression that this difficulty is an excuse for indolence, by the grace of God, without whom we can accomplish nothing, I shall attempt a broader inquiry into these matters. For the number of aids we have to assist our enterprise grows with the interval of time extending from the originators of this art to us. Their discoveries may be compared with what I have newly found. I acknowledge, moreover, that I shall treat many topics differently from my predecessors, and yet I shall do so thanks to them, for it was they who first opened the road to the investigation of these very questions. The universe is spherical. Chapter 1. First of all, we must note that the universe is spherical. The reason is either that, of all forms, the sphere is the most perfect, needing no joint, and being a complete whole which can be neither increased nor diminished, or that it is the most capacious of figures, best suited to enclose and retain all things, or even that all the separate parts of the universe, I mean the sun, moon, planets, and stars, are seen to be of this shape, or that wholes strive to be circumscribed by this boundary, as is apparent in drops of water and other fluid bodies when they seek to be self-contained. Hence no one will question the attribution of this form to the divine bodies. The earth too is spherical. Chapter 2. The earth also is spherical, since it presses upon its center from every direction. Yet it is not immediately recognized as a perfect sphere on account of the great height of the mountains and the depth of the valleys. They scarcely alter the general sphericity of the earth, however, as is clear from the following considerations. For a traveller going from any place towards the north, that pole of the daily rotation gradually climbs higher, while the opposite pole drops down an equal amount. More stars in the north are seen not to set, while in the south certain stars are no longer seen to rise. Thus Italy does not see Canopus, which is visible in Egypt, and Italy does see the river's last star, which is unfamiliar to our area in the colder region. Such stars conversely move higher in the heavens for a traveller heading southward, while those which are high in our sky sink down. Meanwhile, moreover, the elevations of the poles have the same ratio everywhere to the portions of the earth that have been traversed. This happens on no other figure than the sphere. Hence the earth too is evidently enclosed between poles, and is therefore spherical. Furthermore, evening eclipses of the sun and moon are not seen by easterners, nor morning eclipses by westerners, while those occurring in between are seen later by easterners but earlier by westerners. The waters press down into the same figure also, as sailors are aware, since land which is not seen from a ship is visible from the top of the mast. On the other hand, if a light is attached to the top of the mast as the ship draws away from the land, those who remain ashore see the light drop down gradually until it finally disappears, as though setting. Water, furthermore, being fluid by nature, manifestly always seeks the same lower levels as earth, and pushes up from the shore no higher than its rise permits. Hence, whatever land emerges out of the ocean is admittedly that much higher. How the earth forms a single sphere with water. Chapter 3. Pouring forth its seas everywhere, then, the ocean envelops the earth and fills its deeper chasms. Both tend toward the same center because of their heaviness. Accordingly, there had to be less water than land to avoid having the water engulf the entire earth, and to have the water recede from some portions of the land, and from the many islands lying here and there for the preservation of living creatures. For what are the inhabited countries and the mainland itself but an island larger than the others? We should not heed certain peripatetics who declared that the entire body of water is 10 times greater than all the land. For, according to the conjecture which they accepted, in the transmutation of the elements, as 1 unit of earth dissolves, it becomes 10 units of water. They also assert that the earth bulges out to some extent, as it does because it is not of equal weight everywhere, on account of its cavities, its center of gravity being different from its center of magnitude. But they err through ignorance in the art of geometry, for they do not realize that the water cannot be even 7 times greater and still leave any part of the land dry, unless Earth as a whole vacated the center of gravity and yielded that position to water, as if the latter were heavier than itself. For spheres are to each other as the cubes of their diameters. Therefore, if Earth were the 8th part to 7 parts of water, Earth's diameter could not be greater than the distance from center to the circumference of the waters. So far are they from being as much as 10 times greater. Moreover, there is no difference between Earth's centers of gravity and magnitude. This can be established by the fact that from the ocean inward, the curvature of the land does not mount steadily in a continuous rise. If it did, it would keep the sea water out completely, and in no way permit the inland seas and such vast gulfs to intrude. Furthermore, the depth of the abyss would never stop increasing from the shore of the ocean outward, so that no island or reef or any form of land would be encountered by sailors on the longer voyages. But it is well known that almost in the middle of the inhabited lands, barely 15 furlongs remain between the eastern Mediterranean and the Red Sea. On the other hand, in his geography, Ptolemy extended the habitable area halfway around the world. Beyond that meridian where he left unknown land, the modern have added Cathay and territory as vast as 60 degrees of longitude, so that now the earth is inhabited over a greater stretch of longitude than is left for the ocean. To these regions, moreover, should be added the islands discovered in our time under the rulers of Spain and Portugal, and especially America, named after the ship's captain who found it. On account of its still undisclosed size, it is thought to be a second group of inhabited countries. There are also many other islands heretofore unknown. So little reason have we to marvel at the existence of antipodes or antichthonies. Indeed, geometrical reasoning compels us to believe that it is diametrically opposite the Ganges district of India. From all these facts, finally, I think it is clear that land and water together press upon a single center of gravity, that the earth has no other center of magnitude, that, since earth is heavier, its gaps are filled with water, and that consequently there is little water in comparison with land, even though more water perhaps appears on the surface. The earth together with its surrounding waters must in fact have such a shape as its shadow reveals, for it eclipses the moon with the arc of a perfect circle. Therefore the earth is not flat, as Empedocles and Anaximenes thought, nor drum-shaped as Leucippus, nor bowl-shaped as Heraclitus, nor hollow in any other way as Democritus, nor again cylindrical as Anaximander, nor does its lower side extend infinitely downward, the thickness diminishing towards the bottom, as Xenophanes taught, but it is perfectly round, as the philosophers hold. The motion of the heavenly bodies is uniform, eternal, and circular or compounded of circular motions. Chapter 4. I shall now recall to mind that the motion of the heavenly bodies is circular, since the motion appropriate to a sphere is rotation in a circle. By this very act the sphere expresses its form as the simplest body, wherein neither beginning nor end can be found, nor can the one be distinguished from the other, while the sphere itself traverses the same points to return upon itself. In connection with the numerous spheres, however, there are many motions. The most conspicuous of all is the daily rotation, which the Greeks call nocthemeron, that is, the interval of a day and a night. The entire universe, with the exception of the Earth, is conceived as whirling from east to west in this rotation. It is recognized as the common measure of all motions, since we even compute time itself chiefly by the number of days. Secondly, we see other revolutions as advancing in the opposite direction, that is, from west to east. I refer to those of the Sun, Moon, and 5 planets. The Sun thus regulates the year for us, and the Moon the month, which are also very familiar periods of time. In like manner, each of the other 5 planets completes its own orbit. Yet these differ in many ways. In the first place, they do not swing around the same poles as the first motion, but run obliquely through the zodiac. Secondly, these bodies are not seen moving uniformly in their orbits, since the Sun and Moon are observed to be sometimes slow, at other times faster in their course. Moreover, we see the other 5 planets also retrograde at times, stationary at either end. And whereas the Sun always advances along its own direct path, they wander in various ways, straying sometimes to the south and sometimes to the north. That is why they are called planets. Furthermore, they are at times nearer to the Earth, when they are said to be in perigee. At other times they are farther away, when they are said to be in apogee. We must acknowledge nevertheless that their motions are circular or compounded of several circles, because these non-uniformities recur regularly according to a constant law. This could not happen unless the motions were circular, since only the circle can bring back the past. Thus, for example, by a composite motion of circles, the Sun restores to us the inequality of days and nights, as well as the 4 seasons of the year. Several motions are discerned herein, because a simple heavenly body cannot be moved by a single sphere non-uniformly. For this non-uniformity would have to be caused either by an inconstancy, whether imposed from without or generated from within, in the moving force, or by an alteration in the revolving body. From either alternative, however, the intellect shrinks. It is improper to conceive any such defect in objects constituted in the best order. It stands to reason, therefore, that their uniform motions appear non-uniform to us. The cause may be either that their circles have poles different, or that the Earth is not at the center of the circles on which they revolve. To us who watch the course of these planets from the Earth, it happens that our eye does not keep the same distance from every part of their orbits. But on account of their varying distances, these bodies seem larger when nearer than when farther away, as has been proved in optics. Likewise, in equal arcs of their orbits, their motions will appear unequal in equal times, on account of the observer's varying distance. Hence I deem it above all necessary that we should carefully scrutinize the relation of the Earth to the heavens, lest, in our desire to examine the loftiest objects, we remain ignorant of things nearest to us, and by the same error attribute to the celestial bodies what belongs to the Earth.